So let us start. And yeah. So hello, I'm Alex from Megalia. And I work in the Chromium team where we have broad experience of working with customers who run the downstream projects based in Chromium. And this will be a topic of my presentation today. So before I come to the main point, I'd like to make a couple of notes. So first, this talk has a lot in common with a similar one made by Jose, my colleague, in the previous BlinkOn. And he's also author of a series of great blog posts about technical challenges of running a downstream project, with many things about how to maintain your code, how to do this, how to do that. So I recommend a reading if you're interested. Having a similar topic, I will try to give you another perspective. So it's not the repeating of that presentation. And the other thing I wanted to share is that this is a recurrent topic, which we at Megalia feel is important to bring regularly here at this event to highlight this topic and the challenges and everything to the whole community. So I know that in this room there are many people from different companies and who are running the downstream projects. So I hope that you will have questions, and in the end we will have time for discussion. So pictures. This is, I should tell you now that it's the only slide in my presentation that has pictures. It's a spoiler. So there are many projects based on Chromium. And on this slide, I put some of them. To be honest, I cannot name them all, despite the fact that I put them, found in the internet, and so on. There are so many, and some of them I didn't know about them before I did the search. Anyway, mostly those are browsers, and you may say at the same time that not every project based on Chromium is a web browser, right? Because we have, for example, CF, which is the embedding framework, or some other things which are not here. That's absolutely true. Not every project which is based on Chromium is a web browser, but a complete web browser is the biggest possible thing which we can imagine, right? Because it has a renderer, Chrome, services, whatever. So with this complete project, we have the biggest challenge of maintaining the fork. So those complete browsers face the widest possible spectrum of challenges. So I do not question here the reasons why someone, a company or whoever would want to start downstream projects. And the reasons, again, are discussed by Jose in his presentations. But let us assume that we did the decision, so we know that we need it. And let us take a quick look at what a downstream project normally has to do. So we have decided to start a new web browser based in Chromium. What do we do? This is what is displayed on this slide. We might call it like Chromium tuning. And it only needs to, like, we only change some colors or icons or visual things. And this is actually something which for a few projects is just enough. So they just change branding and do a couple of small things, and that's it. But of course, we don't stop there. So in most projects, it's only the tip of the iceberg, and we have much more to do. So we do the effort to bring some unique functions. And just to name some of them, when we want to add like component extensions and probably implement some APIs for them, or we'd like to change the new tab page, which is the thing which many users see all the time when they're working with the browser. So it's a good place to put something important. Also, the features may have some configuration that the users would want to define, and we want to let them do it. And finally, many projects start and risk, like they try to invent something new in the way we browse. It may be some innovative idea about collaborative browsing, or some better ways to handle the browsing history or bookmarks or whatever. So many browsers out there do it differently to how Chromium does it, and puts it like one of the important selling points to attract customers. And such new ideas require new custom UI things like side panels or toolbars or additional controls, or you name it. So those are the changes in the UI. So now when we have the product, we realize that the web browser is not just some program to browse the internet. It's a product that may require support, or we may want to have some feedback, some measurement tools to see how the features work in the world. So we need some like UMA or whatever. And some features require creating user accounts, or synchronizing the data between devices, or processing some data. So eventually we will need to upgrade the software. If we have a large user base, it will be the other challenge. For all those features, we will need the backends. Up to this point, we discussed like standalone web browsers, but there is another direction of customizing Chromium, or doing like the downstream development on it. So many projects do not want to present another new browser to the market, and they do not plan to compete with the big brands. But they may want to bring Chromium to some environment where it didn't exist. For example, it may be some not that popular operating system, or some specific hardware platform, or I don't know. So a good example here is the embedding scenario. For example, like Jose explained yesterday, some low-end devices, like maybe a kiosk with a touch screen and some not that powerful CPU and not that much memory, and lots of examples of this everywhere. So this is where we have a bunch of topics. Most of them are low level. And this is all like optimizations and customizations of the Chromium, which is not aware of every small platform we want to use it on. And finally, this is often not discussed a lot, or omitted or forgotten, but we also have this problem of building the software, because Chromium is massive, and maintaining the infrastructure for doing continuous builds or testing, it's challenges as itself. So, of course, it's a bit borderline, because as I can imagine from the point of view of Chromium, of kind of the upstream project, this is a problem of the customer, because Chromium is big and massive, not because someone wants it to be big, right? It's because it has lots of features, and that cannot be free for the downstreams. But anyway, if we want to benefit from all the features that the upstream has, we have to invest in the infrastructure to build the real code, to test it, and so on. So after we had this overview, very brief, of what could be necessary to run the project, let us have the overview of what is easier, what is not that easy. So on this slide, I collected some typical tasks related to look and feel. And here we have good news that for styling, Chromium has good support. So the themes, changing colors, changing icons is well supported. And it doesn't require any real programming, or requires a little of it. When we come to changes like new layout of new tab page or something like that, it's a bit more difficult, but still it's mainly markup, HTML. Of course, we can, if we want to bring some data views or interactive elements into the new tab page, which are not there, it may easily bring us to the other level of difficulty, but still it's not that much. But I will mention here, but I have a dedicated slide for it, kind of closer to the end. Some projects are ambitious to reinvent the UI, so they do not use the standard one, and that's a long way. It's much harder. Extensions. So adding them is easy because they are kind of intended, dedicated, special way to extend functionality, and that's why the name. And I don't know, I personally did only few times, or I programmed the extension, but it looks like well designed, well thought through. But it's only true while the standard extension APIs are enough for us. When we want to bring a new one, it becomes maybe not difficult, but at least like not easy. So just registering a single new extension API requires changes in about, I think, 10 files, 9 or 10. And most of them are not C++. So we need to register the IDL file for the interface. Then we need to register the permissions and features in JSON maps. And they are located in different parts of the code base. And although they are documented, and there is documentation for this, it's kind of up to date and nice. It's not that easy to do it the right way from the kind of right away. So likely you will do some mistakes and you will spend some time trying to understand what was wrong. And of course, it's only defining it. So when you do the actual implementation, it will require more changes, more code, and so on. Backends. This is a very broad category. But if we are serious about creating some independent product, we'll have to implement at least some of them. And here, the main challenge is that, at least as far as I know, Chromium does not have even the sample or reference implementations for most of the backends. So yes, we have the interfaces, they are sometimes documented. I honestly do not have all the information here, but from the browser side, we know kind of how to send something, but the handling is totally like we need to implement it fully from scratch. And the parts in the browser, they are disabled in Chromium by default, or sometimes just absent. Like for example, the user feedback, which is not on the yeah, it's on the side there. So the UI for it it's not present in Chromium. And if you want to do it, you need to do it by your own. So anything in this category will require substantial effort. You will need to implement servers, maintain them, and enable and probably customize the browser parts. When it comes to other customizations, we are in the wild, so it's hard to imagine all possible ways to change Chromium, and it's maybe even harder to provide extensibility on every possible way. So this topic doesn't have a lot of broad ways, but there is one case which I would like to mention. So when we need to implement to support a new platform, it may sound difficult and massive, but the ozone abstraction layer helps a lot. And with it, we can add the support for a new platform. For a new platform is in quite like straightforward way. So the minimum implementation is, I would not say easy, but if you know what to do, it's doable, and it will not take too much time. So to those who are interested, there is an example. I think it was in the other conference, but my colleague Maxim Sisov did a presentation about implementing a new ozone platform, and he did it in 1 hour during the presentation with some examples. So it's not that much code, and it works. But I repeat, it's only the minimal implementation, and the full way may take years. So the Wayland support, which we were doing, how much did it take? Maybe a few years, right? And we're still not there, although close to the finish. So the custom UI, which I mentioned earlier, some projects replace the entire Chrome with the own implementation. So to have the special look and feel for the whole browser. And this basically means throwing off most UI code and using your toolbox of choice to implement everything for the windows, dialogues, whatever. The good news here is that Chromium does not have the single UI for all supported platforms. So this basically means that you have, well, first, the replacing the UI is doable. You can do it. And the second thing is that you have examples to look at, because like it's already done there. Different platforms use different toolkits. But it will not be easy. This is one of the massive things to do in the downstream. This is what is discussed often, but still I have it here to have more complete picture. So it's a typical challenge, or maybe we should say meta task. So every change which you do in the downstream, it adds to the maintenance cost. So every time the next release comes, you will need to rebase your changes. And the more you do, the more you will have to rebase. And the task is to minimize the cost of doing it. So I will not discuss it here in details, because it deserves a dedicated talk, or maybe even more than one. But just to remember that whatever we do, we will need to rebase it. Now builds and what is related to the builds. So getting power adequate for Chromium, for compiling and testing and whatever, it's kind of painful. Yes, a few years ago, we got Goma, and I think your client is open source too, or no, I'm not sure. But anyway, even having the protocols for the distributed compiling open doesn't mean that we get the actual power. So if you want to compile, we need to set up the farm for the build, or we have some alternatives which are also not free and sometimes not cheap. So still difficult. And also we may want to set up tests and some other automation. And with it, I'm not aware of any standard approach. So kind of with our experience, every customer who is ambitious enough to make this automation do it their own way. So there is no single solution. Now, finally, we're coming to discussions and questions. So after we have taken a look on what downstreams do, let us discuss how Chromium helps the downstream projects and how the upstream could help the downstreams. And before we start discussing it, I would like to mark several aspects here. So in the whole process, the way the upstream could help, or it could be aware of what happens, comes to these things. First, we need to extend or customize Chromium in the downstream projects. Then the downstream may want to contribute back to Chromium. And also, two other things are maintaining the changes and maintaining the infrastructure. And here, I would say that the first part is kind of okay, because helping to extend or customize means writing the code in a way which would be welcoming to do alternative implementation for the things. And this normally comes down to making components with well-designed interfaces. And we have lots of examples in the code where it's done the right way. Like we have extensions, the ozone is just some examples. The backends, although they're not implemented, but we have interfaces for them. And on a smaller scale, in the code, we have many factories which instantiate objects with known interfaces, which is good for testing. And normally, the primary goal is to make something testable for unit tests. But also, it's good for replacing the implementation with something which the downstream project would want to change. But the other aspects are the discussion point. So how could we be more welcoming to contributions from the downstreams? Of course, it may be that the contributor and the upstream, the reviewer, do not agree about if this change has any value for the public. So it's kind of the open question, if something worth upstreaming. Keeping up with the upstream is also the major thing. So Chromium moves forward and it does lots of changes. Some of them are massive, and sometimes they are like not provoking, but people discuss a lot of things like, okay, we have changed the code style, and now we have to change like 10,000 files because we want to realign the lines, whatever. And it may be difficult for the downstreams to follow up like that. And about infrastructure, just the ideas, because I have little idea how could upstream help with this, other than providing some maybe documentation on how to set up your own bots or build farm or whatever. So let us share ideas. What do you think? Who maybe had some painful or difficult thing to do in the downstream and had some ideas how it would be easier if something would be different in the upstream?
We might have time for one question, but then we'll have to move on to the next one. So does anybody have anything? Okay, question from the audience.
So I work on Cobalt, and my part of the job is keeping our infra running and the CI running. And we're very far downstream, and then we do things very differently from the build perspective. We actually started with Chromium, build infra, and so on. I think having a project out there that kind of builds Chromium with some known, like, commonly used infra tools that isn't like Chromium bots, like whether it's GitLab or GitHub Actions or stuff like that is shared across the community, would, as a reference setup, would maybe make that side of the life a little bit easier for everybody. I'm not sure if anybody thinks that.
Yeah, that's a good point, actually. So indeed, although we have many downstream projects and customers can decide what to use, in the end, we don't have that many options. So most of the customers use either GitLab or GitHub, or I don't know if it still exists, the Bitbucket, but there are not so many systems capable of handling large code bases and also providing the means to automate things. Yeah, so I agree. That would be nice. So preparing some recipes for the popular code handling things, like it would be nice. I agree.
All right, I think that's all the time we have. Thank you very much, Alexander.
Thank you.